almost done with this task, kids. Look at this, Algebra 1, Common Core. Here we go, Algebra 1, Common Core. Common Core, the words Common Core just like, ooh. You know what Common Core means to me? Lots of wordy problems. Like when I look at those problems, I'm like, wow, there's lots of words in those problems. By the way, this is January 2015. I am Mr. Krause, but for today you can call me Mr. Key. We are going to do parts 2 through 4. I think that's 30. No, that's problems. No, not 30. That's problems 25 through 37 or something like that. All of this stuff can be neatly found at my website called at www.mrkrausemath.com. Okay, and then click on Regents Review and Algebra 1. By the way, on there you'll also notice that I have a, what's it called? I forgot what I call it. Let's look. www.mrkrausemath.com. You'll notice somewhere, oh my gosh, my Wi-Fi is going, Hall of Fame, my Hall of Fame kids. My Hall of Fame kids, these are students that got 100% Hall of Fame. Oh yeah. These are the kids that I've gotten through. You'll notice I've been teaching for 20 years. These are the only 2 kids I've ever gotten 100 on a test. Oh my God, they were so awesome last year. And then also last year, I worked with a bunch of kids, and there were 2 kids from across New York State that got 100%. This was on the Algebra 2 Regents Exam. However, we are only working on the Algebra 1 Regents Exam. But if you do get 100 and you'd like to be on my Hall of Fame and I helped you, if I didn't help you, don't email me. I will be asking for proof, so you're going to have to send some kind of proof. But hey, you can get on my Hall of Fame, and I'd love to know that I helped somebody else. Okay, I think we're on page 8. Nope, page 9. Nope, page 10. Page 10. Okay, let's get going. By the way, if you're here just to cheat and get my answers, don't do that. That's ridiculous. The only thing you're going to do is fail the Regents at the end of the year. So let me read this question for you. Miss Fox asked her class, is the sum of 4.2 and square root of 2 a rational or irrational answer? Patrick answered the sum would be irrational. Do you agree or disagree? Well, this is sort of an annoying question because it's so easy, but Patrick is correct. It would be irrational because the sum of a rational and irrational number is irrational. Now that's sort of like restating what they already said, so you need to provide a little bit of proof. When I need to provide proof, I slip out the Dunkin' Donuts coffee. By the way, haven't received a dime from Dunkin' Donuts yet. Just saying, Dunkin' Donuts, I'm drinking your lovely brew. It's making my videos so much more faster. More faster. That's good English. Anyway, we got to provide a little English. We got to provide a little proof. So, the number 4.2 is rational, but the square root of 2 is irrational. Irrational. And by adding the 4.2 on to the decimal equivalent. Notice I don't like to, I just get bored with typing. Equivalent of the square root of 2, which is a non-terminating, non-repeating, I misspelled that, repeating decimal. All you get is a larger irrational number. Okay, something to that effect. Basically what's going on is if you take your calculator out and you say, okay, I'm going to add 4.2, which is rational, and I'm going to add to it, not I'm going to add to it the square root of 2. And the square root of 2 is just irrational. All you're going to get is some longer, larger, it's not longer, but some larger irrational number. All right, that's it. I don't know, did they use square root of 2? Square root of 2 is one of the most famous irrational numbers. But let's go on. I hate that question. Blah. All right, so this question's pretty simple. The school newspaper surveyed the student body of an article, and below is what they found. There are 180 students in 9th grade. What percentage of the 9th graders belong to more than one club? Okay, so you got to be careful here. If I add all these up, this is not all of the 9th graders. So that's not really what I want to do. I really only want the ones that are more than, or belong to more than one club. And if I take these two, and I add those up, I get, so 45. 45 belong to more than one club. And so to find the percentage, I just simply take 45 and I divide it by how many students there are. Not by how many students are in clubs, by how many students there are. And that's 180. And if I do that, I believe I get 0.25, which is equivalent to 25%. So the answer is 25% of 9th graders belong to more than one club. Done. Problem's over. Moving on. What's next? Okay. If I included one of these numbers, which one would result in a relation that is no longer a function? Now, a function is a relation that has each and every x value or domain value maps to only one range value. What's that in layman's terms? No repeating x values. So which one of these, if I included it, would all of a sudden have repeating x values? And that would be this one right here. This is the one and the answer to the question. So if -4, 1 were included in the table, then the x value, -4, would map, and that's the terminology they use, would map to two different range values or y values. Or is this f of x? Do they use f of x? F of x values. I probably shouldn't use y then. I probably should be using f of x. Excuse me. F of x values. And then maybe I would add in order a function. The x values can't repeat. Okay, something to that effect. Well, here I am. I'm back. Just curious. I might be in a new. Nope. Yep. I'm in a new shirt for you. I don't know if you noticed at the end of that little part right there, that video or that audio and video got really crazy. So what I've been finding is my video and audio are going crazy. So I have to do these in pieces now. So we're going to do like 2 problems at a time, and then I got to take a break. So anyway, we're going to subtract this from this. Now, your teacher hopefully talked to you about the fact that subtracted from sometimes can be tricky. Subtracted from means you need to do the problem backwards. So, which means we're going to take this first and we're going to subtract this. So 3x squared plus 8x minus 7. And then we're going to subtract, that's terrible. We're going to subtract this thing, which is 5x squared plus 2x minus 1. Oh, is it minus 11? I can't tell. Minus 11. So in order to do that, what you need to do is nothing here. This is fine. This is just 3x squared plus 8x minus 7. But here's the tricky part. You got to distribute this negative. So minus 5x squared minus 2x. And then negative and negative. They always want to test this. Negative times negative is positive 11. Not 1. That's how you make common mistakes. All right, so if I put these two together, I get negative 2x squared. 8x and minus 2x is plus 6x. And negative 7 and positive 11 make positive 4. So there's your answer, kids. That's it. 2-point question. Let's keep moving and rolling. I'll try to do 2 or 3, and then I got to go break and put all this stuff in a video. So solve the following equation algebraically for x. All right, well, I'll probably just have to factor it. So I'm going to bring the 7 over. So I get 4x squared minus 12x minus 7 equals 0. I'll factor this. More than likely, it's going to be 2x and 2x. Remember, so I'm going to try that. We'll start with 2x and 2x, because that multiplies to 4x squared. And there's really only one, there actually is, that's not true. There is really only one way, if you're going to use whole numbers, to multiply to negative 7, and that would be 7 and 1. One of them has to be negative. Let's see if this works out. That's 14, and that's 2. That could give me this, but I want negative, so that has to be negative, and that has to be positive, because that would be negative 14x and positive 2x, and that would give me negative 12x, which is what I want in the middle. To solve these, you do 2x plus 1 equals 0. Bring the 1 over. Bring the 1 over. I get 2x equals negative 1. And divide by 2 and divide by 2. So x equals negative 1/2. There's one of your solutions. 2x minus 7 equals 0. Add 7. Add 7. I get 2x equals 7. Divide by 2. And I get x equals 7 over 2. So your two answers are negative 1/2 and 7 over 2. Oops, shouldn't have parentheses. 7 over 2. All right, let me stop there. Oh, that's only 4 minutes. I can keep going. Let's do one more. Maybe I can do one more. Yeah, we can do one more. You know what? Let's not risk it. The video, if the audio... Well, I just finished doing these. I feel like I'm repeating myself over and over again. Gotta love this computer. All right, if I sound bored, it's because I've just done this problem like 6 times. Oh my God, I need a new computer. This is called a piecewise function. Piecewise function. The reason it's called a piecewise function is it's got 2 pieces. Now, I'm not allowed to graph with arrows on piecewise functions, because I've got a restricted domain. In this one particular case, I have to restrict my domain to -3 to 1. So -3, -2, -1, 0, and 1. Now, 1 is going to be a little bit special, and I'm going to talk about that in a second. The absolute value of 3 is 3. The absolute value of 2 is 2. The absolute value of 1 is 1. And the absolute value of 0 is 0. And the absolute value of 1 is 1. Now, we're going to plot these, but we got to be careful. So -3, 3, -2, 2, -1, 0, 1, or 0, 0, Now notice I put filled in circles for all those, but this one I have to do an open circle for, and that's because there is no equal to right here. Do you see that there's no equal to? It's just less than. And I'm not going to put arrows because I have restricted domain. I can only go from here to here. Now this one's pretty easy. I get to go from -1 to 8. And everywhere it's just going to be 4. So I just come up here. I probably should have a scale. 2, -2, 2. That's good enough. So I'm going to come up here to 4 and closed in circle at 4, closed in circle at 8, and then I'm just going to connect the dots because that's the horizontal line, y equals 4. All right, let's record that. Let's save that because maybe I'll have problems after. Okay, kids, here we go. Problem 31. I've done this one 3 times now. Hopefully, I'll be excited about doing it for the whatever time this is. Anyway, type A. It's 3 feet tall. We're planting trees. It's going to start at 3 feet tall, and it's going to grow at 15. Oh, man. Alert, alert, alert. We have mixed units. We have inches and we have feet. That's a problem. You don't want mixed units. You have to convert them so that they are similar units. In this one, we're going to go 4 feet tall at 10 inches per year. So it wants us to algebraically determine how long before the same height or are equal in height. So let's do type A. Type A starts at 3 feet tall, but because we don't like that, we're going to convert that to 36 inches. So type A, function A will be equal to 36 inches plus 15 inches per year. And we'll define y in a second. B is going to start at 4 feet, but 4 feet again is mixed units, so that's 48 inches, 4 times 12. So B is going to be 48 plus 10y. And we probably should define y. Let y equal number of years. All right. I want to know when they're the same or when they are equal. So I'm going to set these suckers equal to each other. 36 plus 15y equals 48 plus 10y. Very simple equation to solve. We'll subtract 10y, and I get 36, that's a 6, plus 5y equals 48. Something's wrong here, Mr. Krause. It doesn't look like it's going to turn out very nicely. I get 5y equals 12. See, I told you it can't be right. It can't be the right answer. This is probably work from my previous time. We're going to divide by 5 and divide by 5, and I get y equals, now you can use it as 12 over 5, but the answer is 2.4. And that is the correct answer, kids. The trees will be the same height in 2.4 years. That's it. That's it. And we're just doing one problem at a time because heaven forbid I can do 2 at a time. All right, I'll be back. Okay, kids. One of the reasons why I was annoyed to have to do this more than once is because, by the way, this is like the 3rd or 4th time I've done this problem. And it's this problem that makes me mad every time I come over here. It makes me just, ugh. So we need to write an exponential function for this. And I'm not sure how much practice you've gotten with this. So what I'm going to do is I'm going to try to see all the nice points here. There's a nice point. That point is 2, 1. And here's a nice point. 3, 2. And here's a nice point. 4, 4. When I'm done, I want to make sure that these points are going to be on my graph. And 5, 8. Now, the normal equation of a function or an exponential function looks like this. It's f of x is equal to some base raised to an exponent x. And so I don't care what this base is. It could be a 3, it could be a 2, it could be a 4. I don't care what it is. But if you have 2 to the 0 it should equal 1. If you have 3 to the 0, it should equal 1. If you have 4 to the 0, it should equal 1. All exponential functions go through the point 0, 1, unless they have a translation, and that's what we have going on here. We have a translation going on here. It's the simplest way to explain this one. So I'm going to do so in a different color. I'm going to plot points in a different color. Hopefully that got red. No, I don't want red. Let's go blue. Normally it should go here. That's normally where the point should go. So it looks like everything got moved 2 units to the left. So we're going to move all of these points 2 units to the left. And we're going to graph this. Now this function is the function f of x equals 2 to the x. That's this function. So I have to explain what I did. I graphed the function f of x equals 2 to the x, which is 2 units to the left of the equation in the problem. Now, let me just remind you guys something. If you have f of x plus 2, that's 2 units up. If it's f of x minus 2, that's 2 units down. Those are those are translations up and down. Those are vertical. If I have f of x plus 2, that's going to move it 2 units to the left, left 2. If I have f of x minus 2, that's going to move it 2 units to the right. Well, that's what I have here. My original function, or my function that I graphed in blue, is this. If I move it to the right 2 units, it becomes this function. So this function, therefore, the equation in the problem, which is 2 units to the right, must be, now what it is f of x equals 2x. Now because I moved to the right, I got to put it in here, up here in parentheses. 2 units to the right is minus 2, and that is the actual answer to this question. Now if you want to, you can come over and graph it. Take a look at the graph of this thing. Enter and graph 2 raised to the x minus 2. You'll see, hey, there it is, and you can go to the table and look down. 2, 1, 3, 2, 4, 4, and 5, 8. Those are the original points I graphed. So there's the answer to that question. That was a really, I think, hard question. I'm not sure if that was actually a very fair question. All right, we're going to stop there. When I take breaks and get aggravated, I like to drink Dunkin' Donuts coffee because they love Rochester. I should say Hilton because that's where I'm from. But they love Rochester. Dunkin' Donuts is one of my sponsors. The only thing they're sponsoring me is coffee, and they're not even giving that to me for free. I got to buy it. But at least it gets me excited about mathematics and doing these problems. All right, kids, we're still moving along. Now, these problems I've only done twice, not 3 times. So that's good. I'm in a better mood for these problems. Let's talk about Jacob and Zachary. By the way, we're now into 4-point questions. So 4-point questions, you got to understand, when we're dealing with 4-point questions, there's a little bit of work to be done. They're not the 2-point questions. 2-point questions are designed to be pretty quick, pretty fast, not a lot of work. Do you understand a couple of skill sets? But this one, you got some work to do. So Jacob and Zachary go to the movies, purchase refreshments for their friends. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. This is exactly the same. This problem right here is no different than any problem I've done since 20 years of teaching. So we got to write a system that can be used to write to find the cost of one bag of popcorn and the price of one drink. So what we should probably do is assign some variables. Let P equal cost of popcorn and D equal the cost of a drink. So let's talk about Jacob. Now what Jacob did, he bought 2 bags of popcorn plus 3 drinks, and he spent $18.25. What Zach did, I'll call him Zach because Zachary's too much work. He bought 4 bags of popcorn. I guess he's a kind of a piggy, and two drinks. Not so thirsty, but it cost him $27.50. So those are my equations. That's a system of equations that can be used to find the price of one bag of popcorn and one drink. Now I want to use these to actually find it to the nearest cent. So let me copy them back down here. 2D plus, try again, 2P plus 3D equals 1850. 4P plus 2D equals 2750. Now these are ripe. They're exactly set up for what's called the elimination method. The elimination method means we're going to try to get rid of one of the variables. Now the easiest way to do that is to multiply this first equation by -2, because -2 times 2 would be -4P, and when I combine it with this 4P, they'll go away. So I'm going to distribute this -2P, -2. So I get -6D is equal to -$37. Now I'm just going to copy 4P plus 2D equals 2750. These go away. Did I write this down right? Oh, it's 25. I knew something was off. This should be 25. I didn't even copy down the equation right. 25 here, which would make this 3650. So these go away, and I get -4D equals negative, I think that's $9. We're going to divide by -4. We're going to divide by -4, and I get D equals $2.25, I believe. So my drinks are going to cost me $2.25. I still got to figure out what popcorn costs. So I'm going to rewrite that first equation, which is, let's try to get it right this time, 2 popcorns plus 3 drinks equals $18.25. So 2 popcorns plus 3 times 225 is equal to 1825. Now I'm just going to solve for P. 2P plus 675 equals 1825. Let's see. Subtract 675. Subtract 675. Let's see. That's 2P equals, let's see, that'd be 1150. Does that make sense? Yes, 1150. And divide by 2, and I get popcorn costs $5.75. So the answer is 1 drink costs $2.25 and 1 popcorn costs $5.75. Boom, done. All right, I'll be back. Okay, got that one set up. So now we go off to problem number 34. 34, 35, 36, 37. 4 problems left and I'm finished. Yay! At least I might be done for the day. This is driving me crazy. This Slow computer. So the graph of the inequality is shown below. Write an inequality that represents inequality represented by this graph. Okay, so let's get through this. First and foremost, it's got a solid line, so that means it's either got to be greater than or equal to or less than or equal to. We're shading up, so that means it's got to be greater than or equal to. So we're getting rid of that. So we know we're going to start with y is greater than or equal to. There's my y-intercept of 1, 2, 3, so that's down 3. And my slope is up to right 1, up to right 1. So my slope is 2x. There's that. That's the first part. On the same set of axes, graph this. Well, I got to solve for y first. So we'll subtract x. We'll subtract x. So I get 2y is less than negative x plus 4. I put the x first. Now we're going to divide by 2, divide by 2, divide by 2. And I get my equation is equal to y is less than negative 1/2 x plus 2. This was probably some of the tricky part right here. So we'll come up here. Why am I not able to move? Come on. Oh, I didn't have 2 fingers down. Okay, so let's do this in a different color. We'll do this in orange. I already forgot what it was. Negative 1/2 x plus 2. So we're going to come up here. We're going to go plus 2. Now negative 1/2 x plus 2. Now, because this was strictly less than, we have to create a dotted line. And again, it was less than. Y is less than negative 1/2 x plus 2. Less than means we're going to shade in this downwards direction. Now, dotted lines are imaginary lines. They're really not there. They're just imaginary boundary lines. So they're really not actually there, but they're used for graphing purposes. The two inequalities graphed on the set of axes form a system. Oscar thinks the point 2, 1 is in the solution set for the system of inequalities. Determine and state whether you agree with Oscar or not. So we got to figure out where Oscar's point 2, 1 is, and I'm pretty much sure I know exactly where it is. 2, 1, it's right here. So this point is on this line, because that's a solid line. But it is not on this line because this is an imaginary line. So the answer to the question is no, Oscar should have paid more attention in school. So let's explain that to the grader. Unfortunately, Oscar was asleep in algebra, forgot the E, 1 this year. He is not, got to answer the question, correct. The point 2, 1 is in the original function graphed, but it is not in the solution. Y is less than negative 1/2 x plus 2. That's probably good enough. Something to that effect, kids. All right, I'm done with that problem. Woo! Okay, I just got done doing this problem. There, by the way, is the answers to it. I'm going to come back to it. Oh, man. So anyway, I don't know what's going on with my computer. Anyway, here we got a... It's tough to get up to do these problems 6 times. All right, so we got beef hot dogs. We got the amount of calories and the amount of sodium. Just so you know, sodium means salt. So what we want to do is we want to see if there is any correlation. We're trying to look for the correlation coefficient between the amount of calories and the amount of sodium. So in order to do a line of best fit, we're going to come back over to our calculator. We're going to go into spreadsheet mode. And I'm going to call this one up here C for calories and this one S for sodium. And I got the numbers right here. Let me go back to that problem. 186, 181. One of the biggest mistakes made by students is not typing in the numbers correctly. You should really take a look and make sure, it's the best thing you can do, because you got lots of time, is to do these problems twice, just to make sure that you have the right numbers in. Oh, this is hard to do from the bottom. I'm going to do it from the top. So really what you want to make sure is that you try to do these problems twice. Oops. And really check your numbers. 139, 322. If this doesn't work, by the way, you're going to get my crappy sound version of it. 158, 370, 190, 587, 184, 482, 149, 322, 176, 425, 477, and 495. So there we go. Now we're going to do linear regression. So we go into menu, we choose statistics. Or we choose statistics, actually. Well, let's hit escape. We go into menu, we go into for statistics, then stat calculations, and we want to do linear regression. This one, not the other one. We want to do the one that's mx plus b. We called our x list C for calories and our y list S for sodium, and click OK. And again, we don't care about we don't care about anything but the correlation coefficient, and that's the R value. It's right here. So we're really looking at this R value, and that's what we need to write down. So R is equal to 0.942233, but it's around to the hundreds, so we'll say R equals 0.94. So there's my R value. Now you got to explain to the grader what it means. Now this is a 4-point question, so you don't want to explain it in just 2 words. So how about this? Since 0.94 is close to positive 1, it tells us there is a high positive correlation between the number of calories and amount of sodium. That's not good enough. That's not good enough. You need a little bit more because it's positive, which means that as the calories increase, so does the amount of sodium. That's what a high positive correlation goes. As one goes up, the other one goes up. If it was negative, it would be one goes down, one goes up, the other one goes down, or something to that effect. So that would be a high negative correlation. Anyway, that's it. We're done. Hopefully this one worked. Yay, it worked. You didn't have to listen to my bad language. I mean, audio off with the video, excuse me. So given this function, f of x is equal to negative x squared plus 8x plus 9, state whether the vertex represents a maximum or a minimum. So if you don't know that this is a maximum, you can always go over to the graphing calculator and graph it and take a look to see, hey, what's going on here? Negative x squared, so negative x squared plus 8x plus 9. And graph it and see, oh, okay, yeah. Whoa, it's way up there. Yep, there's a maximum. It's a maximum. So how do you know it's a maximum? You should have known it's a maximum based on the fact that the leading coefficient is negative. So the vertex for f of x would, okay, let's try to spell would right, would be a maximum because the leading coefficient is negative, which makes this a parabola or a quadratic facing down. Something to that effect. Rewrite f of x in vertex form by completing the square. So this is sort of a nasty question. So we're going to rewrite the problem originally. F of x equals negative x squared plus 8x plus 9. And we're going to write this in vertex form. The problem with it is that nasty negative. So what we're going to do is we're going to factor out that negative. And we're going to work with just this part right here. X squared plus, x squared minus 8x minus 9. So now we're just going to work with this. We're going to keep that negative coming along for the ride, but we're going to work with just this area. That's why this is a 4-point question, because this part's hard. So with completing the square, you're going to take the first two, x squared minus 8x plus square minus 9. Now if I add square here, I have to subtract square here, because those two things eventually have to cancel each other out. So I'll do negative. We'll keep that going. Now I'm just going to work with this area right here. It's x minus half of this, 4, squared. 4 squared is positive 16. So the 16 goes there, and the 16 goes there as well. Minus, and these add up to, what is that, negative 25. Now, I'm not done. I just got to do this final. I want it in vertex form, which means I got to get rid of these massive parentheses. So it's negative. We'll distribute this negative here. X minus 4 squared plus 25. And that would be the answer. Now, I want to make sure I got that right. So I'm going to hit the tab button here. And I'm going to make sure that I have this right. So negative parenthesis, x minus 4 squared plus 25. And hopefully it maps right over that other one. There it is. It's an exact match. And that means I got it right. Tough problem, kids. Tough problem. Just because of that negative. All right, kids. That's it. I'll be back. I keep saying that, but for you, it's like not coming back at all, is it? Okay, so I'm going to stop, and then I'll be right back. But you won't notice any difference because it'll just keep running. All right. Okay, kids, we are on the last problem of this exam. Let's see what we got going on here. The new Clarendon Park is undergrowing. By the way, this is a 6-point question. That means, hey, it's going to be hard. You got lots of work to show. Hopefully you know how to do this problem. And I think in particular, this is a pretty nasty question. The new Clarendon Park is undergoing renovations of its gardens. One garden was originally a square. It's adjusted so that one side is doubled in length while the other side is decreased by 3 meters. The new garden will have an area, this is the hard part right here, that's 25% more than the original square garden. All right. I think I might show you 2 ways to do this problem, but we'll see. So let's talk about, write an equation that could be used to determine the length of the side of the original square. So let's talk about an original square garden, which would be x by x, and the area would be x squared. Now we're going to change things up a little bit. We're going to double one side while decreasing the other side by 3. Well, the area of this one is 2x times x minus 3. Now here's the hard part. This one's area is 25% more than this one's area. So if I take the original area, I take my new area, 2x times x minus 3. That's equal to the old area, which is x squared, plus 25% more of that area. So I add 0.25 x squared to that. Well, another way to, since these are the same thing, I can write that as 1.25 x squared. And this actually is, and hopefully some of your math teachers are teaching you, is really 125, or is it 25% increase. It's the original 1 plus 25% more. So this is the equation that they were looking for. By the way, either one of these equations would work. Either one of those equations would do. Explain how your equation models the situation. So I found the dimensions of the new rectangular garden and set it equal to the old square garden area, square gardens area, and plus 25% of the old garden. I hope this would be enough. That's kind of what you did, or that's kind of what we did. Determine the area in square meters of the new rectangular garden. So we got to take this equation and actually solve it. So we got 2x times x minus 3 is equal to 1.25x squared. So this one's not actually too bad now. Now, the solving of this isn't too bad. We're going to get 2x squared minus 6x equals 1.25x squared. We're going to subtract this 1.25x squared. And what you end up with is 0.75x squared times x minus 6x. I'm getting to the next step. All right, so got to factor this. Now, it looks difficult to factor, but it's actually pretty easy. We're just going to take out an x, and we're left with 0.75x minus 6 equals 0. So I get two answers from this. I get x equals 0, which can't be the length of a side, so we're not going to use that one. But this one I have to actually solve. 0.75x minus 6 equals 0. Bring the 6 over. 0.75x equals 6. Divide by 0.75. Divide by 0.75. And you get, I believe, 8. X equals 8. Let me just make sure. 6 divided by 0.75 is in fact 8. So the original rectangle had a length of 8. So now we got to use that and say, okay, new rectangle. The width was x minus 3, so the width is 5. And the length was 2x, and that's equal to 2 times 8, which is 16. So new dimensions are 16 by 5. Determine the area. Actually, it just wants the area. So the area equals 80. Now, a quick test of this would be to come up here and find these two areas. The area of this one will be 8 squared, which would be 64. And we just found the area of this one to be 80. So if I take 64 and multiply it by 1.25, it should be 80. So 64 times 1.25, it's an 80, and there's my answer. So the answer in this case, the bottom question, is 80. All right, that's it. Tough question, kids. Tough question. Hopefully you guys survived. Hit the subscribe button. Hit the like button. Come back. Tell your friends about it. Tweet it. Text it. Instagram it. Facebook it. Take pictures of me with my Dunkin' Donuts commercials. I don't really care. I hope you enjoyed it. And I hope it helps you out. Study, 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 kids. Good luck.